Okay, here I want you to try. So let's try together to sketch this particular, to sketch the graph of this particular function. Okay, sketch the surface of the function given y equal to x squared plus z squared minus 2x minus 6z plus 10. Okay, last time what we have done, we sketched a bit simple expression, right? For example, we have z equal to x squared plus y squared. So we know this is a ball. Okay, a ball concave up and open and concave up along the z-axis because we have z here. Okay, but now your expression on your left side, when there is no square, here is y. Okay, if we relate with the ball that we have, what I'm saying this is a ball. Why I didn't say that it's a cylinder? So for cylinder, it should be okay, I have no idea at the moment, but I just want to relate what you have done previously. So let's talk about the ball. If you have z equal to x squared plus y squared, you have a ball concave up and then concave up and parallel to z. Why we know it is z? Because we have a single z here. So meaning that if I give you x equal to y squared plus z squared, so we have a similar ball concave up as well, but it is concave up parallel to x, which means that if you draw okay, the first one, so which is this one, you have a ball concave up and parallel to z because you have z here. But this one, the second one here, down here, you have a ball concave up as well, concave up, but parallel to x. So this one supposedly, if you put y here, this one supposedly z. Okay, but now we have a different situation. If we have just this x squared plus z squared, so we know we have a ball, but now we have the linear term here. You have the linear term of x and you have a linear term of z. So meaning that before you start to find the traces or whatsoever, you have to simplify this. You have to simplify this quadratic. This is considered as a quadratic equation in terms of x and z, because you can see here, you can have the quadratic expression for x squared. You have x squared minus 2x. And you have the quadratic expression for z. You have z squared minus 6z. So it looks like what you can do is you have to simplify the form. So now the question is, what is the method? What is the mathematical method that you have to apply here in order for you to simplify this particular form? Have you ever heard the completing the square? Yes, so completing the square is one of the methods that can simplify your quadratic equation. Okay, especially for quadratic. Okay, so now completing the square, meaning that since you can see the quadratic form is for x and also for z, the meaning that you have to apply the completing the square technique for both variable, for x and for z, meaning that you have to sort them out first. You have to separate, you have to group them, the group x and the group z. Okay, so now we sort them into group, x for x, z for z. So so we have the quadratic equation for x, and we have minus 2x and just constant here, you can you have 10 here, single 10, so you can put 10 in the group of X, or you can put 10 in the group of Z. So it's okay, both can be okay, but either one. Okay, so let's say I put 10 is part of the X family. So now I rewrite I rewrite, okay, the form. So now I have Y equal to, okay, Y equal to X squared. So I group that into a family of X. So minus 2X plus 10. And then the rest is the family of Z. So plus Z squared minus 6Z. Okay, so now I want to implement. Okay, I want to implement the completing the square technique for this group. So I put this, I label this. Okay, and this one is for, okay, so for the double star, okay, for the single star. So now I start to use the completing the square technique. We have the x squared minus 2x plus 10. So how can we apply the completing the square? So some of you just memorize the formula, so it's up to you. Okay, so I don't have a specific formula, but I remember the step. Okay, so I just copy. I have x squared minus 2x, and then I just take the constant of the x power of 1. So we got minus 2 here, whatever value there. So plus minus 2 divided by 2 square minus negative 2 over 2 square. And then I put the plus 10. Plus 10. So this is the step, okay, because I don't memorize. I don't like to use a lot of storage in my head. So I just remember the step, okay, because the idea is this one is become 0. So you add this term because after that you want to factorize. Okay, this one is then this one, because the value here does not change the original expression. This one. So this is become 0. So now we just want to factorize. So in order to factorize or to simplify that, so I just take the x. So x, and then I just take the value after we divide by 2. So I got minus 1. So x minus 1 square. Okay. And then the rest I just calculate this one, negative minus 1 square plus 10. So, okay, and then I simplify the form. So x minus 1 square negative 1. So I got 9. Okay, so this is the new form of the star here, where here I implement the completing the square technique. Okay, so now I can rewrite the form y equal to, so I replace the new form of this, which is I have x minus 1 square plus 9. So now the minus 2x is gone after we factorize this using completing the square, and we have this form. So now you can have x minus 1. So minus 1 in the group of x. Okay, so we know that it looks like x shifted 1 unit to the right. Okay, or to the above, depends on the orientation that you have. Okay, now we finish off the second part, the second term here, double star. Okay, so now for double star, so we have z minus, so this is from double star, z minus z square minus 6z. So in this case, we implement the completing the square as well. We don't factorize because we want to make to have something like z minus a square. So to get this, you have to apply completing the square. Okay, so just use the similar technique as before. This one. So you just copy the first term. I have z squared minus 6z. Okay, now I start to add the term, but that term is the value of that term is 0, which means that the similar technique that I use here, you just choose the constant of x, so you just choose the constant of z here. So plus minus 6 divided by 2 square, and then minus back the similar term so that you will get 0, right? So negative 6 divided by 2 square. And as you can see, this one, the answer will be 0, which means that you don't change the original expression. So now you factorize. So here, so just take z and whatever value that you will get for this term. So you have z, you have negative because negative, you have the negative here. So minus 6 over 2, you will get 3, right? So z minus 3. Z minus 3 square. And then the rest you just evaluate this. So negative, so 3 squared, so minus 9. Minus 9. Okay, so that is your new form of your double star. This one, z squared, this one has been transformed into this using completing the square. So this is the completing the square technique. So then you add this into your y. So plus z minus 3 square minus 9. So 9 minus 9 cancel out. So now your new y is x minus 1 square plus z minus 3 square. So your original expression now, which is quite long, now has been transformed into a simpler form using completing the square technique. Okay, so this kind of question is favorite in exam. Okay. Alright, so now then you can start to sketch. So now just look at what kind of equation that you have, how many variable, the total variable that you have, you got 3, so you have to provide 3 traces. But I'm sure that you can expect, so before we proceed, can we expect what is the surface that we can have, or you should have? Again, refer back to my previous explanation about the bowl. So this is your general form of bowl, where your symmetrical axis is z. Okay, somewhere at the origin, right? Symmetrical line, the symmetrical point, or not point, but the symmetrical line is z, somewhere at the origin here. But if you have something like x minus 1 squared and then y minus 1 squared, it looks like your minimum value is shifted at x equal to 1 and y equal to 1. It's more or less, the form is just like the example that we have here, but now we have a different variable. So it looks like if we are thinking about, we just ignore the minus 1 and minus 3, we can rewrite that into what we can rewrite. So y equal to x squared plus z squared, which means that you have a bone concave up and parallel to y, isn't it? This is x, this is z, and this is y. So your bone is concave up along y. So this is your ball if you have this particular form, where your symmetrical line is along y-axis and you have the origin here as your minimum value. But now you have x minus 1 and z minus 3. So meaning that your minimum point, okay, so minimum point is located at x equal to 1 and z equal to 3. So this yellow ball shifted at x equal to 1, z equal to 3. So where is it now? x1 and z3. So this is 1, this is 3, somewhere here. So your ball is moving somewhere here. So how can I draw the ball? So that is your ball, your new ball. It should be, you should have a similar size. Okay, so that is your ball now. At the point of, that is the minimum point at x equal to 1, z equal to 3. Okay. That is our expectation. Okay, but we have to refer back to the step. Then you have to provide 3 traces. So the 3 traces means, in this case, you cannot use x equal to 0, z equal to 0, because your ball now is shifted at x equal to 1 and z equal to 3. So you have to put at x equal to 1. So what can you see on the plane of x equal to 1 now? So what can you see is y equal to, when you set x equal to 1, so this part is 0, and you can just have z minus 3 square. Okay, so now so we draw the trees. We draw the trees. Okay, on yz plane. So your z at 3. So you have a quadratic, right? Quadratic. Quadratic. Okay, and how can we know this? Intersection at y, so you have to set z equal to 0. When z is 0, so y is 9. Okay. Now we set for z equal to 3 at the plane of z equal to 3. So what can you say? Then you replace the z equal to 3 here, so this part gone. So you have y equal to x minus 1 square. So now we draw the trace. The trace on x plane. So now at x you have 1, and again you have a quadratic shape. So what is your value on y-intercept? You have to put x equal to 0 here, so you have 1. Okay, so now on y-x plane, you have done yz plane, you have done y-x plane. Now how about you have done yz, yx, so zx plane, which means that we set y equal to 0 right on the floor, because your y is here, so meaning that I put your y is just like z before this, so y here, I put y equal to 0. So at y equal to 0, so what can we have there? So then we put 0 equal to x minus 1 square plus z minus 3 square. So it is a circle. It is a circle, no radius, and the center is at 1, 3. It's just a point, right? But your point is located at x equal to 1, z equal to 3. Okay, so we draw that point It should be zx. Zx. So you have 1, x1, 3. Okay, this is 1, 1, 2, 3. So here, that is just a dot. Then we have no idea the shape, right? Then we keep going to increase. Okay, so can we put y negative here? Look at your function now after you simplify into the quadratic form. So we can see that y cannot be negative, right? Because whatever value of x that you put and you square, this one become positive, and this also become always positive. So the total answer here is y always positive, and the smallest y is 0. So we cannot put y negative. So then why not we increase? So I just put y equal to 4. But if let's say in exam they put for specific constant, then you have to follow, okay? You have to follow the instruction. But in this case, not instruction, so you can just set up yourself. So when y equal to 4, at the height of y equal to 4, so you have 4 equal to x minus 1 squared plus z minus 3 squared. So we have a circle center at 1, 3, radius 2. Okay, radius 2. So radius 2 now, and this is the center, radius 2. So 1, 2, 1, 2, 1, 2, 2. Okay, so we have to sketch the circle. Okay, now I label. Just do the labeling. So this one is z equal to 0, and this one is z equal to 4. So maybe we want to know further. Maybe y, not z, yeah, this one. Sorry, because we always have z before this, so this time we have y. And this one may be 9. So 9 equal to x minus 1 square plus z minus 3 square. So here we have 1, 2. We have a circle with radius 3 centered at 1, 3. So radius 3, we have here, we have here, we have here, and we have here. So this circle, we have a larger circle, and this one is for y equal to 9. So we can expect what's next when you increase your level of y. So you will have all the time a circle and circle and circle. Your circle becomes larger and larger and larger. So mean that we know it is concave up. When you increase the y, the height, then if you increase by increasing the y, so that you can have the larger value of circle. So we know we are having the surface concave up. Concave up becomes larger and larger. But if you have concave down, so I don't know how to sketch the concave down. So when you I don't have just like this one. When you have a bowl concave down, so this is your height, maybe in this case z. So when you increase the z, your circle becomes smaller and smaller and smaller. You can see that become smaller and smaller and smaller and become dot. So you know that you have the ball concave down. Okay, so now that is called level curve. So all these called level curves. Okay, level curve. So by combining all the traces, we have traces. These are level curves part of traces. Okay, so when you combine all the traces and also the level curves, then we can sketch So let's say I want to have y here, and this one x, and this one z. Okay. So now your center. So I have to put some scale here. So the center is based on your your level curves. You can see that you have the center is at 1, 3. So at is 1 and 3, 1, 2, 3. So somewhere here. So that will become your center of your bowl. So now we start to sketch. So this is when x equal to 1, which means that your eye, you are looking from this along the x, but now it's on x equal to 1. Okay, so now we sketch that on x equal to 1. Okay, not x equal to 0, but x equal to 1, that here, that plane. So you can see that the quadratic at x equal to 1, not 0, okay, because you set just now x equal to 1. But then, okay, this is incorrect. You look at here, your z is at 3, should be here, should be over here, okay, but along this one, parallel to this one. So that is your quadratic. This one, this one. So this is the in 3D. So you can see that z is at 3. And then when you see from this side, this intersect at a new y-axis here. Okay, at x equal to 1, and the value here is 9. Okay, and then when you are looking from z, when you are looking here, so what can you see on the z equal to 3? At z equal to 3 now. So at z equal to 3 now. So at this plane. Okay, so you can see this quadratic. So your quadratic now is on y-axis plane. So this is 4, and this is the other side. Okay. So when you watch from this side, so this one is at x equal to 1. Okay, at x equal to 1. And then you intersect at somewhere the value is 1, but it's hard for you to find out where is the one here. So that's why you need to provide the traces easy for you to look, okay, because this is the other side, you cannot see that clearly. Okay, and then your level curves, so you can see that right on the floor, which is y equal to 0, you can just see a dot right on the floor. And then when you increase by increasing the y, you can have a circle, and you can have a circle, and you can have a circle. So that is your bowl. Now it's shifted at x equal to 1 and y and z equal to 3. Okay, so that is your sketching now. Whereas expected, so this is our expectation just now, we have this one. And now you can show it from all the steps that you have provided there. Okay, so as I mentioned before, this is exam-like question. Okay.